Alright, what's up, Hive? It's Ron B. the Science Sheet, and a long-awaited video is finally here. During an early astro vlog, when I was looking at the sun, I said I was going to talk about the sun cycle and sunspots. So here it finally is. So this is like episode 2 of my Solar series, and yeah, here we go. Alright. So we're going to start off with the sunspots. The sunspots are areas in the sun, on the sun, the surface of the sun, where the magnetic field is a lot denser and a lot stronger than the surrounding area of the sun. And so what ends up happening is that as the magnetic field gets stronger, the temperature of that area gets relatively cooler. So when you're looking at the sun through a filter, the filter it's so opaque. It's opaque enough so that it dims out a lot of the sun. But since it dims out a lot of the sun, relatively that dark spot also gets a lot more dimmed out to the point where it looks black while the rest of the sun is orange. I hope that makes sense. To further explain it, that sunspot still has a lot of light, but it's not as bright as the surrounding area. So when you dim everything, the whole thing gets dimmed out. So this fact is so important because with this magnetic field that's super dense, that is how we get all of our solar activity. And that is going to be a separate episode on this Solar series, where I'm going to talk about solar flares, and I'm going to talk about Now we're going to take a closer look on these sunspots. So on the image you're seeing right now, it is a image taken from the Big Bear Solar Observatory in California, owned by and ran by New Jersey Institute of Technology. And in this image, it's very close up on the sun. You can see that dark spot is the sunspot, where it's a lot less, where it's a lot cooler than the surrounding area. And you can kind of see how it looks like a lot of those lines kind of looks like filament lines that are going into that kind of abyss right there. And those lines are following magnetic field lines, because since the sun is made up of plasma, right? And plasma is just ions, so positive and negative ions. But the funny thing with plasma is that there's an equal amount of positive ions and an equal amount of negative ions. If you're not familiar with what an ion is, it's just an atom with a charge. That's it, atom with a charge. So yeah, the plasma, since it's an ion, it has a charge, it's going to follow the magnetic field lines in either, whether it's negative or positive, either in negative or positive direction. But that's why the filament kind of has is going that direction. And you can kind of see on the side where there's kind of like these sections where it looks like it's kind of like in cubes. I forget what those are called. I believe they're called like gradients or something, gradients. But on this next image, you can see a comparison to those subsections, little shapes, to the United States of America. And so yeah, that's how big they are. So when you're looking at those sunspots in those astro vlogs, those are about like the size, they're at sizes comparable to the Earth. So that's just something to think about. They're really big when you put it into perspective. And this last image you see is again another image from the BBSO telescope, where you can see the light that's coming at those sunspots. Next, we're going to be talking about how sunspots are actually tracked. You've heard me say before that we're in a solar maxima, but what does that really mean? So the sun cycle is the cycle of when there are low amounts of sunspots to high amounts of sunspots. So it's very interesting that the cycle only revolves around how many sunspots are on the sun. And so data has been tracked back from like the 1700s, because that is the earliest archives that we found of astronomers who have looked at the sun through a telescope, and they've drawn out what they saw so you can actually see the sunspots. And that's how we have data from all the way back there that we can use now and compare. But the sun cycle, it averages to 11 years. It's not always going to be 11 years. You know, it has some uncertainty, but it averages to 11 years. And we have a solar maxima. Once we get to that solar maxima, that's when we have the most amount of sunspots and the most amount of solar activity. That's why it's very important, because the solar activity, as I said before, I think I said it before, I hope I said it before, but yes, because the magnetic field is dense and that sunspot, that's where we're gonna have a lot of activity because of that magnetic field. But yeah, that's why it's so prominent. Those are when we have the solar maxima. 2024 to 2026 is this solar cycle solar maxima. Then, you know, it's gonna be less sunspots, and we can finally get to our solar minima, where we're not gonna see a lot of solar activity. And what's funny, or what's interesting, is right now, you know, all the heliophysicists, the space weather scientists, the people who are just studying the sun or even stars, they're all excited now, because this is the prime time to do any experiment where you're trying to study a phenomenon about the sun. However, if you're trying to put a spacecraft out, if you're an astronaut, you know, you want to do a mission out into space for any particular reason, now is not the best time to do it, because with the solar activity comes those coronal mass ejections, those solar flares, where things are getting emitted, and now you have more dangers with your missions. We're gonna talk about that later, because I want to make sure that's a whole separate video that's gonna be more elaborated. But for now, just it's important to know that there's a solar maxima and a solar minima. And so what actually happens is, as we transition to a new part of the cycle, what happens is the magnetic poles on the sun actually flip from north to south. So that's what this big change is going about. Something really interesting about the solar cycle, really fun fact, is that during one particular solar minima, and I believe it was around 1755. Let me fact check that. Okay, no, it was from 1645 to 1715, and we call that the Maunder minima. It was a period where there was like very little sunspots. And what's interesting about it was, as there was very little sunspots, as we were in a solar minima, the Earth actually went through a small little ice age. During certain parts of the Earth, they had an ice age. So even though there isn't really it's a like coincidence. Some scientists do believe that small effects on the sun, as far as, you know, the activity that happens from the solar activity, can affect the Earth and its climate. There isn't that much strong evidence for it, so it's more something that, you know, could be correlated, but we're not really sure. Something to be studied, but it is an interesting fact to know. I think I'm gonna end this video off here though. Hope y'all learned a lot. More is coming out. If you liked the video, go ahead and give it a like. Go and subscribe if you haven't already. And if you didn't like the video, go ahead and like and subscribe. Ron to be out.